Hey everyone, this is a quick video on how to build a robot from scratch. So I'm going to be using a 3D printer. I'll just show you that over here. So this is my Ender 3 Pro and I'm going to be building a SMARS robot. So we're going to start, assuming you know nothing about this, we're going to show you all the steps required. So first of all, I'm going to open up a new browser window. I'm going to go for smarsfan.com, which is a website I've created, and over here we've got a button that's how to build the robot. So this is what we're going to be building, one of these robots here, the little SMARS with the tracks. Straight away we can see on the instructions there we're going to be printing the chassis of the robot. So this is the main body of the robot. So if we click on that chassis button there, it'll take us to the sort of parts where we can download these STL files. So you don't have to worry about what that is. It's the sort of instructions for the 3D printer on how to print this. So I'm going to download that. It's downloaded it here into my my downloads folder. So I'm now going to open up Cura, which is the slicing software that we need to use. So okay, so I've opened up Cura, and what I'm going to do now is open up that file that we've just downloaded. So I'm going to click on the little folder here. I'm going to go to the downloads folder and I'm going to click on that file that just downloaded. So let me just move across to the date added, and there it is, chassis.stl. So we can see there we have the little chassis sat on top of the printer. This is the printer bed. This is effectively going to be this area here. So what we need to do now is slice this file. So let's go over to the preview so we can see what this is going to look like, and we're going to press the slice button. So I use a number of settings by default. I'll go for the standard quality. We can set that to the super high quality, and that prints much more granular resolution. We can go for the standard quality. There's not much between the two of them from a quality perspective. This one will take much longer. So if I just keep the changes there, and we can have a look and see what difference that makes. When I click on the slice button now, it'll tell us this is going to take a number of hours to print. So let's see what that number will be. So it says 7 hours 51 minutes. Let's just change that quality to be standard and see what that looks like. Again, I'm going to keep the changes there. I'm going to click slice. So 7 hours 51, let's see if we can beat that at all. And we've now got 4 hours 39, so it's at least an hour and 10 minutes quicker. And the actual quality of it is still good enough for what we need. So the other things I've got on here is I've got a little skirt around the edge. I'm not using a brim, that's not necessary, and I'm not using a lot of support structures. I think there are some support structures in here. We can tell there, just that area. So in this wheel stub here, because these are interesting structures, we do need a little bit of support. So I have enabled the support structures in the settings. So if I go to the support, you can see that we have everywhere means build the print structures within the actual chassis itself. So that's good, we want that. So what we do now is we say save to file, and I'm going to save that file to the desktop, and I'm just going to call it chassis, like so. And what I will do now is I will open up, first of all I'm going to switch my 3D printer on. So I've got my 3D printer. I'll just show you on here. On my phone I've got some plugs I can remotely control on here. So I've got two buttons, one for the Raspberry Pi and one for the printer itself. And what that's going to do, if I just go over here, that's going to come to life any second now. There we go. You can see the little, that's the BL Touch sensor, which helps bed leveling, helps us do a really nice first layer. Okay, so I'm just going to log into my Octoprint window. What I'm going to do next is open up a browser window. So let's go back over to the desktop, and I'm going to open up Octoprint. So let's have a look at this. So this is some software that I use to control my printer. Not everybody has to use this, and effectively what this is a Raspberry Pi connected to my 3D printer, and I can store files on it, and then I can leave it be. So we look at our 3D printer now. It's now placed the print head in the middle of the thing. This isn't switched on yet, it's not heated up. And the first thing that I like to do, because this sometimes takes a while to do, is heat up. So I know that 200 degrees for the hot end and 50 degrees for the bed seem to be the right settings for me. I always get good prints with them. I do them both at the same time using Octoprint. I don't have to wait for one before I can do the other. And now what I will do is I'm first of all going to make sure my print head is, let me just show you over here, is aligned, so it's just, I've just sent it a command to say home, so the X and Y is homing. And now for the Z, if I just go back over to that screen there, I've got a plugin installed called Bed Visualizer, and you can see there my bed isn't quite level. And if I do update my mesh, what will happen now is it's going to take 9 readings from the bed. It does it in a sort of pattern of square pattern, so 3 on the top, 3 in the middle and 3 on the bottom, and it just takes a couple of seconds for it to get these readings. You can see there the little BL touch sensor drops down. It'll then find out where the point is on the bed, it'll record that. It's going to go to the middle now, so it's doing the middle right, and I'll probably speed this bit up because this bit's a bit boring, so we'll do the next bit in time lapse. Okay, so now if we go back over to the browser window, we can just see it's just refreshing the visualization there, and we can see one end of it is slightly high, one end of it is slightly low, but overall it's not bad, it's not badly leveled there. And by taking this mesh, it can then figure out, does it need to move the motor slightly down and slightly up as it's moving across the bed, and therefore ensure a really good first layer. So if I now go back over to the temperature, we've now hit the right temperature. I can now upload that file, drag it actually to the desktop. So what I'm going to do is open up a window, and I call that file chassis.gcode. I'm going to drag that across there, and what that's going to do is going to upload it to, just see there it says saving the files, uploading it to the Octoprint, so to the Raspberry Pi itself. Once it's done that, it will update the top of the screen there. We can see G-code has now been uploaded a few seconds ago. So I'm now going to load that by pressing that little folder button. You can see this area here is now updating. And now we're ready to print. So I press print. We can look over now on that screen, and we can see that in a second the printer is going to move the head to the home position. Just looking to see there on the screen, and I can see these temperatures are all good. We're 200 degrees, and actually it's changing it to 60 degrees, so it's just having to heat the bed up a bit more. It probably doesn't need to be 60. That might be one of the settings that changed when I changed the settings from standard to super high and then back to standard again. But that's not a problem, it's nearly there now. That's one of the good features of the Ender Pro 3. The Pro bit is it has a 24 volt power supply, so it can actually pump a bit more juice into the heated bed, which is the thing that takes the longest time. The actual hot end doesn't seem to take too long. Right, so now that it's done that, we should see it's now homing the bed. Now what I usually do is I'll take some of these clippers. Let me just quickly show you this. I've got some of these clippers, and what I will do is I will just make sure that piece of filament that's just extruded out, I'm going to make sure that that is not clogging up the bed. Sometimes these things sort of string out and they can ruin the first layer. So it's now just doing one more check to see that it's centered, getting its Z. It's going to remember that mesh that we took a couple of seconds ago, and now it's going to do its first layer. So here we go. It'll do a line on the left hand side which just extrudes a bit of filament. You can just see there now that it's extruded. You can see that very first bit's a bit messy, but that's why it does the first line, just to unclog the hot end. And now we should start seeing it do the skirt. So this is how we know that we've got a nice level bed. We can have a see, how does that look? Does it look like it's solidly fastened to the bed? It's not dragging it out, it doesn't seem to be moving around. It does seem to be a really good first layer. So I'm quite confident I could walk away at this point and come back 4 hours later, 4 hours and 39 minutes later, to a chassis. So it's going to do this about 3 times, I think, to do the skirt. Yeah, that's looking like a really good layer. You can see there that it's very consistent. There's no stringiness or anything. So what I will do, I will leave it recording, not for the full 3 hours, but I will leave it recording a little bit, and then we'll come back to it when it's finished. So that's how we start printing off the chassis. The other parts, the wheels and the motor holders, the rangefinder cover and the rangefinder holder, they're the main parts that we'll be printing. Just looking to see on one of our similar robots, and the tracks as well. So this is the rangefinder cover, the rangefinder holder, the chassis is just there, we can see, and the wheels and the tracks as well. That's all we need to print one of our SMARS robots, so we shall come back to that in a few hours time and see how we're getting on with that. So I hope you find this interesting, and see you in a couple of hours time when it's finished printing. Okay, so it's the next day now, and let's have a look how the print has got on. So we can see there it's just finished printing. It's about 4.5 hours to complete. I've not taken it off the bed yet. I wanted to show you how exactly I would do that. So let me just get one of the tools that I use. So one of the tools that I use is this knife. It's a blade. Let me just show you what this looks like. So it's got very sharp edge to it. See if I can get that there. You can see it's a little bit worn actually because I've been scraping away with this. But this is sort of perfect for sort of scraping at things without damaging the edge. The blade is that sharp that it can get underneath the print, between the print and the print bed, without scratching the print bed. Now I have got it on a magnetic bed as well, so there's a number of different ways that I can do this. Either I can just lift this up, and when it gets to the print there, it can sort of peel back. You can just see there that it's coming off. Or I can just use this tool to sort of do this kind of motion where I'm sort of slightly twisting it. And if I do that all the way around, and then apply a little bit of pressure there, it'll start to give. There we go, I feel it's going now, and off it comes. So let's have a look at this a bit closer up. So as it comes off the bed, you can see there it's still got some of this support material around it, and the support is inside the holes. See if I can get this a good view of this. So the support material is in there, and inside there is no other support material, so that's a really good print. Really nice and rounded and smooth. There's a little bit of banding, I think. I don't know if you can quite see that on here, but there's a little bit of banding. There you go. So you can see there's a little bit of banding on there. I can feel it slightly, but it's not too bad. To look at that, that's a great print. So I have got an Arduino here. Let's just plug this in and see what this looks like. So what will happen when we come to construct our robot, we will actually just slide this Arduino into those two slots. Now the first time you do it, it's going to be a bit, requires just a little bit of force. There we go. So you can see there, that's now going to slide into place like so, and that's going to be how the robot holds the Arduino up. We need to just take that out because we're not quite ready for that yet. And what I will do as well, I will get my tool and I will cut away these pieces of support material. Usually they just require a bit of a twist and a pull, and sometimes it requires quite a bit of work to do. Sometimes it's very easy. This one's going to be a tricky one to do. Sometimes they're easy to come off, sometimes they're not. And you can also see there is some support material there, so that one we can probably just pinch the edge of that and peel it away, and it should sort of come off quite simply. Let's just put that to the bed so we can see what we've got. Okay, let's just get the rest of that out there. Now depending on what settings you've got on the support, will decide exactly what support material is applied to the print. So I've gone for this sort of zigzaggy, I think it's called zigzag. Okay, and then let's try and see if we can get this off in one go as well. Bit of a twist, and there you go, it comes out like a plug. That was much easier to do, and then there's just that little bit just on the side there. There we go, and that's it. It's a little bit rough there. We could probably smooth that off with a bit of a file, but the wheels will certainly go on there fine, no problem. You can see there's not a great deal of wastage. Now what I usually do with the this skirt that's on the print bed there is I'll get this blade again and I'll just find a little edge. I don't want to damage the surface, so I just get a little bit of edge, and you can see it almost change colour, and then this should probably come off in one piece, like so, and similar with that. I've got a little box that I keep all the spare bits in, it makes it easier to clean off. There we have it. So the next steps are going to be putting the motors into place. So I haven't actually removed that tiny little piece from in there. I can actually just push them through like so. That's just a tiny little piece. So yeah, putting the motors in place will just be a matter of putting them through there. You can nearly almost click into place like so, and that's where the wheels will go. So the powered wheels will go there, the unpowered wheels will go on there, and we put our battery in the middle there, so that will go sort of in there. Now there's two motor holders that we need to print that will hold that in place, but effectively that's how we get our robot built. That's going to go on top. We're going to have a motor shield that goes on top of there. When I've wired up the motor, so there's two other wires coming through there, they can come underneath and into the motor A and B, and the power from the battery can go into the power just on the side there. So what we'll be printing next is one of these components. So let's have a look what's involved here. So we've got our Rangefinder module. So there's two parts to print. There's the Rangefinder holder and there's the Rangefinder cover, and there's one that will just slide into place. So this yellow version will just slide into the front there, like so. The Rangefinder module will just slide into there, like so. And then the front cover can sort of go into place. I always like it so that that arrow piece is facing up. Let's just do that for a second, push this into place. Nice tight fit. When our Arduino is in place, that actually holds that in place there so it stops moving about. And we can then just take our DuPont wires and sort of plug them from there into where we need to on the board on this one. And that's how our Arduino starts to come together with the SMARS robot. So next we'll print out the Rangefinder cover and holder. So let's go back over to smarsfan.com and pull that up to our printing the wheeled robot. And now we want to look at the Rangefinder. So that's the Rangefinder cover. So we're going to download that, Ultrasonic 1. And we also need the holder. So let me just find that holder, which is there. So I'm going to download that too. So now that I've got both of them, I can load them both into Cura at the same time. We can print two things at once. So let's do that. I'm going to click on that there, which is our chassis. I can click on it from the object list and just remove it by hitting delete. And now I can go back into the prepare view, click on the little folder, and then go into the downloads folder, Ultrasonic 1 and 2. So let's grab both of them. There they are. So we can now see we have Ultrasonic 1 and 2 on the board, and that's all we need to do. So let's just slice that. We can leave the settings as they are. They're on the standard quality. That's more than sufficient. And this is 1 hour and 46, so not too bad. So if you remember before when we printed the chassis out, it said it was going to be 3 hours 49, something like that, and it actually took 4.5. So I clearly haven't quite got the settings in Cura correct to make it accurately estimate this. So I reckon this will be about 2 hours 10, something like that. But let's give it a go and find out. So I'm going to save that file to the desktop. I'm just going to call it Rangefinder. Okay, and then we can click on Open Folder, and here it is. So Rangefinder is there, and I just need to drag that across into the window on Octoprint. So let's just go back to that, Rangefinder, drag that across to the left hand side. That's now going to load up in the bottom there. There we go, and all I then need to do is click the little folder icon to load that into there we go, into the next print to be printed. Now, because we moved when I did this before and I lifted up the magnetic bed, I will have actually adjusted very slightly the height of the bed. So we need to do that bed visualization again, but what I will do is I will do the 200 degrees, and I think was it 60 before. I'll set that going, and then I'll do the bed visualization. It might change ever so slightly if the temperature changes, the bed visualization, but I found this is fine. It doesn't. It's so minute that it doesn't matter. So again, let's go back over to the overhead. We can see that it's doing its bed leveling very slowly, going up from the height of the chassis. It must have been quite high up. Was it 30 millimeters? So it just had to come down from that, and there we go. It's going to do its 9-point calibration once more. So I'll skip this bit forward again, and we can then see it put down that first layer. And once it's reached the temperature, it'll just take a couple of seconds for it to realise that's nice and stable, and then it will start printing. So very nearly there now, 60. So let's have a quick look back over on the print bed itself. It's just going to wait a second for that to stabilise, and then we'll start seeing it print. Printing any second now. So again, I'm just going to check to see if there's any filament underneath the print head. I'm just going to remove it. So there's a tiny little piece just there. So I'm just going to leave that. Put that in that box. You always get a tiny bit of dribble at the end of the nozzle. So it's just going to do its Z calibration once more. And I'm just checking to see is there any more extrusion come out the bottom, because I would clear that off if there was. But that first wipe we'll get rid of that as well. So here we go. Here's the first line that it's going to do. There we go. Yep, so there's a tiny bit of stuff there that was not quite right, but that's fine, we can leave that. So now it's going to lay down that first skirt. So this will be around the entire circumference of the print, and I'm just checking to see, does that sort of pull away at all, or does that look like it's a nice solid line? That looks pretty good. Now I can see on the print bed there is a piece of loose filament. I'm just going to move away with my finger in a second, because I don't want that getting caught in the design. So you can just see that there's a tiny piece. See that it's so small. Right, let's go back over to the bed. Let's see what's going on with that first layer. That's looking pretty good. I can now see the outline of the rangefinder. So I can see that sort of coming together. Now what I want to show you just while that's starting to print, I'll show you the difference between different printing beds. So when I started 3D printing, I had an ANET A8 clone that I bought from China, and it had a glass bed, and one of the problems was things wouldn't stick to the bed very well, because glass is very, very smooth, and the filament, when it's heated up and deposited on the surface, will cool quite rapidly. So even though I've got a heated bed, there's nothing making it really adhere to that surface. So what I would have to do, I've still got it in here, is use some kind of glue on the bed. I tried hairspray, that just ended up making everything sticky, but I would use some kind of glue. This is called Pritt Stick. I think is it Yoo-hoo? There's other varieties of glue, but essentially it's this white glue. It never quite sets, this glue, it just remains tacky forever. So that means if you printed something on it, and I printed something here, I don't know if you can see the roughness of that surface, but also bits, fibres, all kinds of things end up sticking to that, and it ends up looking quite rough. Now compare this to one printed on the Ender Pro. You can see just how different those two are. This one's got a much flatter, perfect surface to it, whereas the other one has got kind of a rough surface. You can see the actual lines of the print as well, whereas on the top one it just looks like a flat surface. You can't see any of the print marks at all. So there we go, just thought I'd share that with you as well. Let's have a look, see how that's getting on now. So we can just see it's kind of like this shape is just coming together, printed that way up, and we can just see behind it there is that kind of shape being printed as well. And it looks almost translucent when it starts off, but that's looking like a really good print. I know in about an hour and a half, just over's time, that'll be a perfect print that we can then add to our robot. So if you're enjoying this video and you want to learn more about robotics, why not check out my website? So smarsfan.com is a website that I've created to capture everything to do with SMARS robots. We have the wheel version as well as the quad-legged version, and you can find all the instructions that you need on the website. along with tutorials, the code to make them bring to life, and there's also a store there to buy components from too. So that's the first thing I need to sort of bring to your awareness. And the second one is that every single week I will do a live stream on a Sunday evening. It's currently about 7 PM GMT. And here's all the different time zones around the world. You can see there on the sort of left-hand column we have the Americas and Canada. On the middle column we have Europe, Pakistan, India. And then the right column we have China and Australia, I think maybe Russia as well. You know where you live, you know roughly what that is. I just want to try and give you an idea of when this happens. So I'll go live, we can interact with the audience. It's always great for me to talk to people, or the people who are on the way, on the journey to building their own robots, and just understand where they're up to, and maybe I can learn some tips from you guys as well. So have a look at the website, let me know what you think about that, drop a comment if you think anything should be added to that, and yeah. So thanks for watching the video, and I shall see you all very soon.